Hey guys, welcome to Cloud Computing. This is an overview of Lab 4. So the first thing we want to do for this lab is to learn and to master Docker, and we understand what we mean by a Docker image, and we understand what we mean by a Docker container. And then I want you to run a custom Docker container based on a custom Docker image that we are going to build in the lab. So first thing is to go to compute engine and to create a new instance, and I will call this instance basically Docker host. Now you need to be careful to select the custom image that I provide for you from my project, and be careful to select the image called Docker engine. Now I have Docker engine, select it, then go down, allow HTTP, and then create the first VM for this lab. While the VM is created, I want to show you another feature in Google Cloud Console, which is the Cloud Shell, which I find it very useful. When you click on this button here, it will activate a shell at the bottom of the screen, and this shell is used to communicate with everything inside the project. Everything you have in terms of VM instances, cloud databases, storage, and so on. So the shell will be prepared, and we are going to use the shell to access the VM in the same way we used to access it using SSH session. But I find this shell is much better for the coming labs and the coming tutorial to use. Now you need to wait for a few seconds until the shell is activated. Now the shell is active. I want to connect to this Docker host, so I will do GC cloud compute and then SSH and the name of the instance, and this is going to be Docker host. Now I am in Docker host. So the next step is we want to basically check whether Docker is installed in this VM or not. So we run this command, which Docker. Now we want to check whether we can run Docker without the, sudo. So if we don't have a username added to Docker sudo, we want just to do this check. Now if I just type any command in the shell, and I will say Docker, for example, run hello world, this will ask me to run as a sudo. To do that, as explained in the lab sheet, you just need to paste a simple command to tell the VM that your user belongs to the Docker group, and this Docker group is going to be added. So just put sudo usermod -a g capital and then Docker, which is the name of the group, and then the username that we are going to have. Now this is your username. So basically the username is your student number. So D161246992 is my user number. Now you have to reboot the machine in order to make this command take effect. So I will go to the VM and just restart it. So this is where we reset the VM. And now hopefully we can communicate with it again. So I go to the Cloud Shell again and do the same steps. You can access from here as well if you would like, if you prefer this method rather than just the Cloud Shell. It's up to you to decide. The next thing we want to do is to start doing the tutorials from the cloud, from Docker document. So we need to go to the tutorial part in this link here, which is Docker documents, get started, where you will find very useful information to do. I want you in this lab to do part 1 and part 2. No need to do part 3, 4, and 5, and 6 at the moment. You can do them if you want by installing Docker in your laptop and then you have to practice them. But later on I'm going to show you how you will do part 3, 4 and 5 on the cloud. So the VM is ready. Now I go back. Again, I will connect to this VM. And the last step, based on the tutorial, as you can see here, once you have installed Docker, which is basically you don't need to do so because we already have Docker installed, you need to run this simple command, which is docker run hello world. Now go back to the VM and just run docker hello world. You should be able to run it without the need to sudo. Now this image is not available locally, as you can read from the output that I received from Docker. So basically what it did, it pull it from Docker Hub and then it run it in your VM. And you can see here that the image has been giving me an output, as you can see in this line. Now after you do all of that, go back to the Docker tutorial and finish them. Just finish until part 2. By this you should be able to finish part 1 and 2 of this lab. Now for part 3 of this lab, I want you to clone a repo, and the link for this repo is available in the lab sheet. It's called lab for base image. So this is the repo that I want you to clone. Now go inside it, do cd lab for base image. You will see that there is a Docker file and there is my app folder and there is a readme file. What you need to do is to build this image. Now building the image in the same way, where you run docker build -t and you give the image a name with dot. Dot means read the Docker file in the same folder. Now this is what's going to build the image for me, and it will take a few minutes to finish because it has to install Ubuntu, install pip3, install Python 3, it will install MySQL client, it will install all the dependency that we have installed in lab 3. But now the whole process of those package installation and dependency installation is automated using Docker engine. So we don't need to worry about this anymore. And you just only create a Docker file. And this Docker file will be like a guideline. Every time you want to build this image or to build this software will be used in order to build the software in the same way you built it in your machine or in your laptop. Now the image has been successfully built. So the next step is to check that we have a new image using this command docker images. So here I can see that there is a new image called my web app, and this is the image hello world that I used before. Now after that I want you to run it. So we just put this simple command docker run -p8 port 80 and port 5000. Now to understand this, 5000 is the container port. This is where the container exposing the traffic. Now what I'm doing is a port mapping. So I'm telling the VM to listen to all the traffic coming from port 5000. So once you click in the external IP here, you can read everything exposed by the container. And this is basically the same application we did in lab 3. Now once you have this and you want to check, for example, whether Docker is running or not, or the image is running or not, just do this command, which is basically docker ps. This will give me a list of all running container on the machine. After that, I want just to basically stop the running container. I could just do so by typing this command, and this is going to be docker stop, and then I need to get the container ID in order to stop it. Now the container has been stopped. So if you go back and you refresh the page, you won't be able to save or to check the result after the container is stopped, because there is nothing exposed to the external world from the container. So this is basically what you need to do for part 3. Now for part 4, In part 4, we want to create another dev machine. So we will go and create a VM instant, and this will be called a dev machine. Now we need to exit from this VM because we are going to basically use this shell to access another VM. I will call it dev machine. Okay, and this is going to be based on my custom image, which is the Docker engine. So this is Docker engine, select, and then allow HTTP traffic and create. Now the VM is created. I will access the Cloud Shell in the same way we did before. Close all unneeded tabs. Now the dev machine is basically running. What we want to do is to connect to this VM and do two things. I have an image which registered in Docker, so you can just pull it. Basically, you can just pull it from Docker Hub and run it straight away. You don't need to worry about building the image. And this is the sweet thing about Docker. In the same way, I will connect to this VM, GC Cloud, compute, and then I will do SSH to my dev machine. Now I am in the dev machine, which is good. By the way, you can maximize this, or you can hide it, or you can open it in a new window as you like. And it has also a preview for any web app running here. It's a very nice tool to use. Now what I want to do in this part, which is the last part for today, is to pull an image from Docker Hub using this command, docker pull basil web app. Okay, again, it's asking me to activate basically the Docker user using sudo. So just I will add here sudo because this is only just to show you how I'm going to do it. Now this is running and pulling the image from Docker Hub, and this image will be ready for me just to run straight away in the same way we did when we built it from scratch. Okay, so now the image is built, so I can just do quick check that the image is there. So sudo docker images, and then check the Docker image is there. Now the next step is to build it and to run it, to run this image. So I'm going to run it using this command. It's asking me for sudo privilege. So whether you do the trick we did before, or you just do sudo as I did here, and this is basically what I have now. Docker ps to check that the container is running. So this is my container, it is running, and from the external IP I could just visit the application. So this is what we need to do from part 1 to part 4, guys. Now for the final part, which is part 5, which is a challenge for you, I want you to create a Git repo, and you pull this repo into the VM. You can decide whether it's Docker host or dev machine, and then you want to create a Flask application based on your knowledge of Lab 3. Now you will have to expose 2 routes. There will be 2 endpoints for this application. The first one will return index.html, which is basically you just display a short bio about yourself, and then another route which is contact me, and this will be to send an email to your email address, whether you use a HTML form or you just use the href reference I put in the lab sheet. Then create a Docker file and create a requirement file, and then basically build the Docker image, run it as a Docker container. Submit this URL to the lab report and show it to the tutor demonstrator, and also put the lab for repo URL in the report. And this is all you need to do, guys, for lab 4. I wish you enjoy it and see you all in the lab. Thank you.